Hello, ladies and gentlemen. Now I will present our mini project. Our topic is a big data system designed for the voice of students platforms or VOS. So the university receives feedback from students through many different ways, like emails, forms, social media posts, even audios or videos. All of these things come in different formats, different structure, and different level of menaces. So before we can get any insight out of it, we need a proper system to manage everything. And the main problem is the student feedback that the university gets is scattered, unstructured, and unclean. Some is text, some is audio, some is video, and it's full of slang, emoji, mixed language, and duplicate. So our goal is to design a system that can collect, clean, store, and analyze this message in multi-format feedback efficiency. From the circumstance that I just mentioned, we categorize the incoming data into three types: structured data like survey, semi-structured data like emails, and unstructured data like social media or audio record. Unstructured data is the hardest because it requires a heavy cleaning. And especially social media. There are mixed Thai and English, typos, emoji, spam, and everything. That's why it is a strong cleaning and processing pipelines is essential. And this is our system design diagram, and I will walk you through it quickly. As you can see from the topmost layer, we have all the feedback source: text, email, social media, audios, and videos. All of this flow into Kafka or Fluent, which acts like our intake system, making sure we can handle spike and continuous system of data. From there, everything is stored in data lake. We split it into three zones: raw zones for untouched data, clean zones for processed data, and analytic zones for ready-to-use data. Then we use Apache Spark as our processing engine. Spark does the heavy work: text cleaning, sentiment analyzing, audio to text convert, and even extract metadata from the videos. After that, Sparks finish. The cleaned data goes into the data warehouse. Finally, we visualize everything in dashboard, where departments can quickly see the trends or urgent issues. So this whole design gives us an end-to-end pipeline from messy feedback all the way to actionable insight. And this is our data ingestions, which shows how each type of input, text, audios, videos, all the things that I mentioned before, how they enter the system through its own investigative parts. But everything is unified under Kafka, so the system stays scalable.
We store data in multiple layers to keep things organized. Raw data stay untouched, clean zone hold processed data, and analytic zone is for dashboard. This slide shows the flow for each data type. Even though text, audio, and video come in differently, they all go to Spark. This is the heart of our processing. Spark clean text, removes noise, convert audio into text, analyze sentiment, and classify topic. This transforms messy feedback into structured information and ends up in the data warehouse. Next, analytic and insight. Student satisfaction trend, top report issue, word crowd and keyword frequency, department specific and analytic, real-time dashboard for decision maker. So why did we design it this way? Kafka is great for real-time and high-volume data. A data lake lets us store everything: text, audio, and video, without worry about structure at first. Spark is powerful for large-scale processing, especially unstructured social media data. Speed to text. Let us treat audio feedback the same as text. Elasticsearch speed up keyword search, which help with urgent campaign. And a multi-zone data lake keep the whole system clean and manageable. Everything here solves a specific challenge of handling messy student feedback.
Benefits. This design brings a lot of benefits. Real-time monitoring of student sentiment, a single platform for all kinds of feedback, much cleaner data after processing, faster response to urgent issues, scalability as the university grows, and is set up nicely for future machine learning tasks. Basically, it turns chaos into clarity. Other suggestions. There are also a few improvements we can add later. Automatic alerts when negative sentiment spike. A live chatbot to make it easier for students to submit feedback. A feedback tracking page like submitted in review, resolve. Multi-language detect, PDPA anonymization layers, and even ML scoring to popularize urgent issues. This would make the system smarter and more user-friendly.
And about the security and privacy, we also include PDPA features, encryption, anonymization, access control, and logging. And here is the workflow. This slide shows the entire journey from submission to engagement, to lake, to processing, to warehouse, to dashboard and alerts. And for the tools, we use Kafka, Flume, HDFS, S3, Spark, Python NLP, Elasticsearch, and BI tools like Tableau or Power BI. About the conclusion, to wrap up, our system solves the problem of scattered, unstructured student feedback. It provides a complete pipeline, strong justification, clear benefits, and plenty of room for future enhancements. Thank you for listening.